All right, now we're going to be talking about geometric sequences and how to turn a geometric sequence into a geometric rule. So in general, this is what a geometric rule looks like. And what I really want to draw your attention to is this raised to the power of n here. If you remember back, when we were looking at linear rules, so when we come up here, this was our linear rules. Do you see how you just times the n? You just times the n. But when you've got a geometric rule, you don't times the n, you raise the n to the power. Why on earth do you do that? That's going to be really important that we understand why we're doing that. And if you can walk away from this part of the lesson understanding why, when we've got a geometric rule, you raise the n instead of simply timesing it, I will have done my job. If you don't understand by the end of this lesson, you need to come find me. We will talk about it. All right. You've got a whole bunch of stuff here, which is really good to look back on once you've got a good understanding of what's going on. So you've got a table here that shows you how each recursion relation corresponds to each of its general rules. So you've got geometric growth, geometric decay, reducing balance, depreciation, and compound interest, all of which have their corresponding things here. We're going to talk about all of this later, and I want you to refer back to this later. But for you to understand what is exactly going on, I want to jump into this example here because I feel it's going to be very important in just explaining why it is that we're raising it to the power of n. So that's what we're going to go through now. We're going to go through this, but we'll come back and talk about this later on. All right, let's go through this rule and understand what exactly we're doing.